Okay, I want to go over a couple of the problems from the homework quickly. A 0.05 level of significance corresponds with a 95% honor confidence interval. You want to make sure that alpha plus the confidence interval is equal to 100. So if it said a 0.1 level of significance, you'd be using a 90% confidence interval. According to the null hypothesis, for the means of two independent groups indicate that there is no statistically significant difference, which means that the average of group 1 equals the average of group 2. And that would be example like men and women smile the same. That was our null hypothesis. The null hypothesis always states that it doesn't make a difference, whatever it happens to be, whether it's gender or classification. Number 3, compared to the 0.05 level of significance, the 0.01 level of significance means when you move from a 0.05 level to a 0.01 level of significance, your confidence interval gets wider. Let me show you. Right? If this is 95% confidence interval, it means that in each tail, there is a total of the alpha divided by 2. So here's going to be 0.025, all right? So each tail is worth 0.025. Add those together, that's 5% of the tails, and the confidence interval here is 95%. The 0.01 gets you even further here, correct? So that we got a 99% confidence interval. So as you can see, the confidence interval becomes wider, which means that you have a lower probability of the obtained difference being a result of sampling error, right? Because your confidence interval is wider, right? Because it's wider, you have less of a probability of it being a sample error because you've got more space. You're very unlikely to get it out into these little tails here. If the calculated t-value is smaller than the critical value of t, we reject the null hypothesis, right? So what that looks like is here, if this is my critical, let's say this is minus 1 plus 1, and it said if my critical value is less than this, all right, let's go to the positive side. If it's less than that, and let's say we're 0.5, we would fail to reject, all right? Fail to reject. If it said something about being on this side, like negative 0.5, then you would accept, but that's probably a poorly written question. I think the best thing to say is if the obtained t is between the two critical values, you want to fail to reject. These are your rejection regions. Only reject if it falls into these areas here. So the answer here was false. Number 5, if we retain a null hypothesis that is in fact false, we have committed a type 2 error. Number 6, testing the difference between means or proportions requires random sampling. That's absolutely true. 7, testing the difference between means requires measurement at the ordinal level. That's false. In order to do any of these statistics that we have done lately, you have to have at the interval level, ratio level, because you need to be able to add numbers and get medians and get means and also get standard deviations. When I have ordinal information in name only, like 4 people have red hair, 2 people have brown hair, it's very hard to get the average brown-haired person and divide it by the average redheaded person. So number 8, the critical value for assessing the difference between two proportions at the 0.05 level is 1.96. You know this because when you go to the t-table and you look up alpha equal to 0.015, it always spits out a critical score or a table t of 1.96. So that would be your regions. Your 1.96 would be this would be your negative 1.96. Sorry for the handwriting. And this would be your positive 1.96. You will learn to memorize that. The larger the value of our attained t, the less probable that our results are due to chance alone. So that's sort of how you get rid of the sampling error. When you get into the larger values of t, then you can think that there must be a difference. For example, because remember what I'm doing here is I'm taking the difference between two means. I'm dividing by the standard error. So that number, as it gets larger and larger, it means there must be some sort of significant difference between the two means. Number 10, the null hypothesis states that two samples have been drawn from equivalent populations. That's a true statement. All right, the social researcher wants to test the hypothesis that college students who drink alcohol while texting the average number of keystrokes with a non-driver 134, what is your T-score? So the good news is this gives you everything that you need. So the way to set this problem up, I'm going to use a Word document here. All right, it gives me the numbers. So what you're going to have is you're going to have the square root of, and this is where it's going to get kind of funny, but I'm going to have 50, which is N1, times the average, which it gave you as saying that the variance for the first drinker was 7.45. You want to make sure that you square that number. If you don't, your numbers will be off. Plus 50 N2 times the standard deviation of the second group, which was 6.81. And that's what I saw most people did not square. All right? All of this divided by 50 N1 plus N2 minus 2. And you take this term, and then you're going to multiply it by that next term, which is just N1 plus N2 over N1 times N2. So I'm going to have 50 plus 50 divided by 50 times 50. All right? As long as you set this up, you should be fine, but I'm going to go ahead, and it's sort of hard for me to do all the math, but I'm going to attempt to do it. So then you'll still have the square root of 277.575.125 plus 2.318.805. All of that divided by 98. Everything kind of reduces down to that. Then you have this term, 50 plus 50 is 100. So I still have that multiplied by 100 divided by 50 times 50, which is 2,500. All right, I still gonna have square root 5093 divided by 98 times, that other term reduces down to 0.04. So now I have the square root 51.98 times 0.04, which just is equals to the square root of 2.08. When I actually take the square root, I'd get then that the standard error of the difference of the means is equal to 1.44. Now that I have that, I can calculate it into my t-ratio formula. So your t-ratio is just going to be equal to the average minus the other average divided by 1.44, which is going to give me 8 divided by 1.44, which just gives me 5.56. So my t-score here is going to be 5.56. The next question I can move this over. All right. ask what are the degrees of freedom? Degrees of freedom in the problem here is going to always be N1 plus N2 minus 2. You always have two groups that you're comparing. Sorry, I'm trying to see if I can get the old screen back in. All right. Type 1 error has been made. 14, the sampling distribution differences between mean approximates a normal curve whose mean is 0. The symbols for type 1 error and type 2 errors are often beta. The t-test can be used for testing the same sample measured twice as well as for two independent samples. That's a true statement. When we retain the null hypothesis, when we retain the null, we conclude that the sampling error is responsible for any obtained difference. Right? So we said before, no matter what you do, you can never get rid of sampling error. But when we retain the null, we're saying if there is a difference between these two averages, it is done because of sampling error. If we had rejected the null, we could say, oh, look, there is a difference. And it wasn't due to sampling error. Which of the following exemplifies a research hypothesis? Men and women have different levels of income. The reason this is a research hypothesis is because two things are different. If it had been the null hypothesis, it would have said men and women have the same level of income, or gender doesn't matter when looking at income. Which statement is true of alpha? Conventionally, social researchers set alpha to equal 0.05. If the problem doesn't give you an alpha, always assume it's 0.05. And then with respect to alpha, which of the following statements is true? Alpha is the level of probability at which the null hypothesis can be rejected with confidence, right? So that's all alpha is. How confident are we that we can reject the null hypothesis?